All right, good morning. I'm just going to go over a few of the problems on the Chapter 7 review for you, with you. You'll have to finish up the rest of the review once I am done, and you have some work time. So I just wanted to go through the vocabulary like we always do. So the first one, what is the asymptote for this exponential equation? Please remember the asymptote is always going to be the plus or minus number that's on the end. So the asymptote is going to be at, y is equal to 5. It's whatever plus or minus number is on the end of the equation. Okay? Number 2, identify the decay factor. And this isn't something we talk too much about, but it's just the idea that whatever number is being raised to a power is how much something gets decreased by in an exponential decay problem. And so that's going to be the 0.89. So the decay factor is 0.89. Number 3, explain the meaning of log base b of y. So essentially what we need to do, is we essentially need to call that something. So we could call it something like holiday tree. And what they really want us to do is just change this from a log expression to an exponential. So what does log base b of y mean? It means that b raised to an exponent holiday tree is going to be equal to y. Remember what happens? The log base becomes the number base. A logarithm is an exponent. So holiday tree becomes the exponent. And then whatever we were taking the log of becomes what the exponential is equal to. Number 4, a logarithm with base e, which of course we would denote ln, is called a natural logarithm. And number 5 is y is equal to 1.4 raised to the x, an exponential or a power function. And remember our definition, anything with a variable in the exponent is called an exponential function. Right, so this would be an exponential function. Okay? Alrighty. So those are the first 5. Those are your 5 vocabulary problems. And then what I'm going to do is I'm just going to select a problem or two from each of the sections that I would think you might normally ask about, and just go through them with you. If you've already done them, you can move ahead. As an example, I might do number 6, but if you've done number 6 already, you can just move ahead to 7 or 8. Okay? So a couple, at least one from each section then. As an example, number 5, graph y is equal to 5 to the x. On your test, I'm going to ask you to graph 6 exponential functions. And so the idea on any of those is to create an xy table and start with the number that makes the exponent equal to 0. So in this case, that is actually 0. There's no plus or minus, so you actually get to use 0. Then we just simply go up and down one, up and down another one. And then put those numbers in for x, so y is going to be equal to 5 to the negative 2, 5 to the negative 1, 5 to the 0, 5 to the first, 5 to the second. So we're just simply putting the numbers we selected in for x and punching out the y. I'll start on the easy side like I normally do. 5 squared is 25, 5 to the first is 5, 5 to the 0 is 1, anything to the 0 is 1. And then the negatives are a little bit tougher. Feel free to use your calculator, but remember, negative exponents have to become positive. So 5 to the negative first is 1/5, and 5 to the negative second is 1 over 5 squared, which is 1/25. Okay? And then we just need to graph those. So I'm just pulling up a piece of graph paper. It's not going to be quite big enough, but you guys will get the idea. Oop, I'm going to select red so it's easy to see. So the first ordered pair go left 2 up a 25th. Very hard to draw. It's so close to the x-axis. I'll just do the best I can. Left 1 up a 5th. Also difficult, but I'll do the best I can. Stay in the middle, go up 1. That's easy. Right 1 up 5. Also easy. And then the one that doesn't work is right 2 up 25, because my graph only goes to 10, but we just end up with a point, way the bejeebers up on your graph. And when we do a connect the dot puzzle, and extend, what we should get is this graph that gets terribly high, terribly fast to the right, gets really tall. And then to the left, flattens out, flattens out, flattens out, flattens out towards the asymptote. And on the test, I'll ask you to show me where the asymptote is. Here it's obvious, it's the x-axis. But on any of the other problems, I'll ask you to put in the asymptote as a broken line. Okay, so make sure you practice that on these examples. Okay, so there's number 6. I'm going to let you guys try 7 and 8. It's the same thing, just putting in different values using your calculator to punch them out. Next, though, I'm going to switch back to white so it's easier to read up front here. Next, I'm going to go to 9. And this is one of the money problems like we did in class. So we're going to need to use our equation for money. So a sub t is equal to a sub 0 times 1 plus r divided by n raised to the n times t power. And you should have in your notebook what all the different variables mean. Okay, so in this problem it says find the balance after only 2 years. So the amount of money is not going to have much time to grow here, but we'll do it anyway. The initial amount of money is $1,500. The interest rate is 7%, but remember you got to change that to a decimal. So 7% would be 0.07. And then it says compounded daily. And so n, compounded daily, means every day of the year. So it's going to be calculated or compounded 365 times. So the n value is 365. And then again, the number of years is 2. So the calculation that I need you to make on the test would be perform the arithmetic inside. So 0.07, oops, sorry about that. Hit the wrong button. So 0.07 divided by 365 plus 1 is about 1, and we need some more decimal places than we're used to because we have all these zeros, so we need quite a few decimal places. So I'm going to go 1.000191, and then we're going to have to raise that to the 730th power. All right, so when we raise that to the 730th power, we get approximately 1.15. And when I multiply that by 1,500, I get $1,725.39. So that would be the amount of money in the account after 2 years. It doesn't go up by a terrific amount, but it's only a couple of years, so you kind of understand. Okay? All right. Next, I want to do one of the exponential decay functions. So one of the exponential decays. And I think I'll pick the hardest one. And I believe the hardest one for everybody is going to be number 12. So we'll go with that one. So we'll have f of x is equal to 2 times 0.8 raised to the x minus 1 power plus a 3. And again, we're going to use an xy table on all of these folks. And what we do is we start with a number that makes the exponent equal to 0. And that number would be 1. 1 minus 1 is 0. And from the 1, we go up and down from there. All right, and so we just put those numbers in for x. So y is going to be equal to 2 times 0.8, raised to the negative second power plus 3. We put in 0, we'll have 2 times 0.8 raised to the negative first power plus 3. We put in 1, we'll have 2 times 0.8 raised to the 0 power plus 3. We put in 2, we'll have 2 times 0.8 raised to the first plus 3. And finally, we put in 3, we'll have 2 times 0.8 squared plus 3. So we just need our calculators to punch those out. Again, I'll start on the easy side. 0.8 squared times 2 plus 3 gets me 4.28. 0.8 to the first times 2 plus 3 is, I hit the wrong button there, sorry guys. Plus 3 is 4.6, sorry about that. Anything raised to the 0 power is 1, so 0.8 to the 0 is 1. 2 times 1 is 2, and 2 plus 3 is 5. And then the ones that are a little bit harder than negative exponents, 0.8 raised to the negative first power times 2 plus 3 gets me 5.5. And finally, 0.8 squared times 2. Oop, gosh darn it, I knew I was going to do that. I said it wrong, guys. 0.8 to the negative second power. I knew I was going to do that, darn it. Times 2 plus 3 is 6.125. Okay? All right. So then I'll pull up my graph paper and scooch it over a little bit so we can see. I wonder if I can shrink it just slightly. There we go. Oh, so, all right. So I think that'll be okay with everybody. Now remember from the review again, any plus or minus number on the end is the location of the asymptote. So in fact, we could put that in right away and get that over with. And now we just have all the ordered pairs. Left one up, 6.25. So left one up, 6.25. Stay in the middle, go up 5.5. Go right one, up 5. Go right 2, up 4.6. And go right 3, up 4.28. All right, and so I'll just do the best I can. So this is a decay, so this is going to flatten out, flatten out, flatten out to your right. And kind of slow but sure, get bigger and bigger to your left. All right, so the graph would look something like that. Again, I think that's probably going to be the toughest one in that group of 3. So now you should be able to back up and do 10 and 11, I hope, fairly well. Okay? All right, let's move on to section 3. And I don't know if you guys need any help with the graphing there. Again, it's just a calculator problem using your E key on your calculator. So I think you should be okay. We did enough of those in class. You should be okay. But I did want to do the word problem in section 3. So I want to do 16 for everybody. And 16 involves physiology, and it gives you some explanation about something called nitrogen 13. But what it comes down to is it gives us an equation that reads N equals 6.9 times E raised to the negative 0.0695 T power. So it gives us that equation after all of the explanation. And then what it asks is how many picograms of nitrogen 13 remain after 10 minutes. So what they want us to do is put in 10 for T. All right, so they want us to replace the T with 10 minutes and then just simply punch out the math. We could multiply these two numbers together. So we'd end up with negative point, essentially the 0 disappears, so negative 0.695. And then we could enter this into our calculator to get the approximate amount of, what was it again? Nitrogen 13. So 6.9 times E raised to the negative 0.695 power. And if I punched okay, I got approximately 3.44. And I forgot the abbreviations, picograms. I think that's PG, if I remember right. You could check with Mr. Hohenstein or Mr. LaFond on the notation. I think we use a P for pico and G for grams. Okay? So even though it sounded like it was going to be a very difficult problem, it turns into something where it's really just a calculator problem, being able to compute the value when time equals 10. All right? Then the next batch, section 4, goes through some logarithm stuff. The first handful, the first 4 are all problems they want you to do without a calculator. The idea being, as an example on 17, guys, they give us the log base 3 of 243. And so what we did in class was we said, well, let's call that something. Let's call that something like cloud. And then what we did was we changed the log to an exponential. Now remember, an exponential is a number raised to a power that's equal to something. And the way it went again, the log base became the number base. What the log was equal to is the exponent. So that's cloud. And what we were taking the log of becomes what the exponential is equal to. So to figure out cloud, what we have to do is then just use our fingers and start multiplying 3's together until we get to 243. So I wish you could see me. I'm holding up my hand, and I'm just going to start multiplying 3's together. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3 is 243. And what we ended up with is 5 3's multiplied together. 5 3's multiplied together. Okay? And again, I'll just let you guys try the other couple there. I'll let you guys try the other couple. Alrighty. Then the other one I wanted to do from this section was the word problem, the biology problem there in number 24. Again, it sounds like it's going to be terribly difficult. They're talking about researchers and looking at the size of the pupil in a person's eye as they get older. But what it comes down to after all of that explanation is this equation. The diameter of a person's pupil is going to be negative 2.1158 ln of A plus 13.669, where A is the person's age measured in years. So what they then ask us in the problem is, they don't letter this, but there's essentially two parts. They say, can you find the diameter of a person's pupil when they are 25 years old, and then when they're 50 years old? And so with all that explanation, what it comes down to is, can we do the computation? Can we use our calculator to punch out all of that arithmetic? And it's fairly easy. We just put in negative 2.1158 times the ln of 25 plus 13.669. And what we get, excuse me, what I get out as a result is approximately 6.86. 6.86, and I'm just looking back for the label. Oop, that was in millimeters. So it'd be 6.86 millimeters. And then I'll let you guys try the second one. I'll let you try the second computation. Okay? I'll let you try that second one. Okay? All right, moving on to section 5. What we're doing here is applying the properties for logarithms that we talked through together. All right, and there's two that we worry about. One is called an expansion, and one is called a condensing. And I'll just pick one of each from this section just to put it back in everybody's head. The toughest one in the first batch is number 28, because it has both multiplication and it has division. All right, it has multiplication in the top, 3 times y, and then it has division, 3y divided by x to the 5th. The directions are expand, and so when we expand a problem, guys, we start on the left-hand side of the rules, and we work to the right-hand side. So as an example, the first thing I would bump into is multiplication. So the rule for multiplication says that's going to be equal to the log of the first plus the log of the second. So the multiplication turns into addition. Second, the division turns into subtraction. So the log of two things divided turns into subtraction. So that would then be minus the ln of the denominator. Okay, and we're almost done. We can also apply the third rule, though, because the third term has an extra power. And remember, the third property says if you have an extra power, you can pick that up and slide it down in front of the log. So your best answer is ln of 3 plus ln of y minus 5 ln of x. Okay? So that's the toughest one in that first batch. And then in the second batch, the toughest one is probably 31. So let's choose that one. The directions now go the other way. So instead of expanding, we're now condensing. Let's see, a 2 minus an ln of 8. So these go from right-hand side to left-hand side. So you look at your notes, and you just have to go the other way. You have to start on the right-hand side and go to your left-hand side. And the one we always begin with is there an extra number in front of any of the logs? In this case, yeah, there's a 2 in front of the ln. So what the third rule says is you can pick that up and make it the extra power on the 3. We could pick up the 5 and make it the extra power on the 2. There is no extra number in front of the third log, so we don't have to worry about it. Okay, so that's the one we always do first. Then what we can do is we can take the addition and subtraction and turn this into one log by multiplying. Remember, the addition now is going to turn into multiplication for the first argument and the second argument, and then subtraction turns into division with the third. Okay, so our best answer is ln of 3 squared minus 2 to the 5th divided by 8. Okay, so that's going to be the toughest one in that second collection. 29 and 30 should be a titch easier than that. Should be a titch easier. Okay? And then finally, I'm not going to do too many of these last sections because we just spent 2 days in a row going through these in class. So these should be real fresh in your memory. But the problems in section 6 are solving equations with either exponential equations or logarithmic equations. Okay? And so I'm just going to bob through 2 of them fairly quick. It shouldn't take much. All right, number 32 as an example. 5 to the x power is equal to 32. All right, solve. Find the value for the variable that makes this true. Okay? Well, 2 strategies. One is called equality. Can you make the number bases the same? Obviously, 5 and 32 aren't the same right off the bat. Can you make them the same? Can you think of a way to write 5 as a power of 32 or 32 as a power of 5? No. So if that doesn't work, then you have to use inverses. And the inverse of exponentials are logs. So what we're going to do is we're going to take the log of both sides. The log of what base? Well, the key again, remember, is to look at where's the variable, right? And we're going to use the log base that's the same as the number base. So the x is attached to a 5, so we have to use log base 5 of both sides. And whatever you do on one side, you have to do on the other. So we'll take the log base 5 of the left and the log base 5 of the right. On the left-hand side, since the log base and the number base are the same, those two cancel each other out, and we're just left with x. On the right-hand side, the log base 5 of 32. Some of us can use our calculators to punch that out. Others would need to do a change of base formula, and as I've mentioned in class, I don't have one of the fancy calculators, so I'd have to do it with the change of base formula. So it's just going to take me 1 second to punch that in, and I get approximately 2.15. Okay? Alrighty. So I think I'm going to call it a day there. I'm using up about, well, just a titch under half of the hour. So now what I'd like you guys to do is get going and work on the rest of the chapter review. Remembering again, sorry to be a broken record, but the chapter 7 test is going to be on Monday the 22nd. All right? So remember, your chapter review is always due the same day we take a test. So make sure you get this review done so you can turn it in on Monday when you walk in the door to take the test. Okay? All right, so get going on this assignment and get yourself ready for the test, and then we'll see everybody on Monday. Have a good day. See ya.